Okay, afternoon guys. Welcome to the Martin Audio webinar training. My name is Ben Tucker. I'm a product support engineer at Martin Audio, and today I'm going to be talking you through a little bit about Martin Audio and Dante products. So in this webinar, we're going to have a brief overview of Dante. We're going to have a quick look into the Dante-enabled Martin Audio product. We're going to have a little look into network basics and configurations for device control. As well, we're going to have a look into discovery and routing of Martin Audio devices within ViewNet. We're going to have an overview of Dante Controller, and we're going to have a little look into network configurations for Dante devices. Now, this is very much an introduction to Martin Audio and Dante. There's nothing particularly complicated about this webinar, and there is a link at the end to a bit more advanced Dante learning from Ordinate. So first of all, this Dante is based on industry standards. Ordinate, an Australian company, created Dante, which is an uncompressed multi-channel digital media networking technology with very, very low latency and synchronization. The nice thing about Dante is that it uses common IT standards, therefore it's IP-based. It also uses simple human naming protocol between devices and device channels, so we don't need to know any complex programming. As you can see in the picture there, things are simply named Ben Control PC and IK42, for example. And since it's completely digital, we don't have to worry about common analog challenges of interference from other electrical equipment, crosstalk between cables, or signal degradation over cable runs. So setting up a Dante network is really simple. All we do is plug in all the Dante-enabled devices into an Ethernet switch and connect the computer running Dante controller to that network. So it's that easy to set up and configure and manage. Because Dante-enabled devices discover one another over the network, they learn each other's capabilities. So things like input channels, sample rates, bit depths, etc., and whether they can talk to one another. In order to make that integration with existing networks easy, Dante auto assigns unique IP addresses for each device, or if we've got DHCP on the network, it will receive an address from the server. It also uses standard Cat5e, Cat6, Cat7, or indeed fiber cable, and will work with a wide variety of standard network switches, and it can easily coexist with other IT systems. Ordinate do actually publish a blacklist of switches as well as some recommended ones on their website if you're unsure what route to take when you're setting up Dante networks. Both Dante-enabled products, the Dante cards within our products, and ViewNet products, so things like iKon, CDD-LIVE, etc., which we'll look at, support static IP addressing. But for a quick and easy integration, we recommend using unmanaged gigabit switches with DHCP support, ensuring a true plug-and-play system. Now, as I mentioned, that is quick and easy. It's a simple matter of plugging things in, and everything should discover by itself. So let's have a look at our iKon amplifiers and indeed our DX4.0 processor. Both of these feature fully redundant Dante audio networking using the Ordinate Brooklyn 2 chip. iKon itself has 4 independent uncompressed receive channels of Dante audio, and in the latest firmware version, as some of you may know, the iKon 81 has 8 channels of Dante audio. The DX4 processor hosts the same Dante IOs as the 81, but of course, being a processor and not an amplifier, it does also have transmit channels, which is an 8x8 processor in Dante. Both of these are capable of receiving digital audio up to 192K and anything right down to 44.1. So it's nice and flexible with the standard equipment out there. And ViewNet works in the same way as Dante in that it is working over standard Ethernet connections. So they can both coexist on one network alongside any other traffic. And the Brooklyn 2 chips in these devices can be configured down to 1/4 of a millisecond, and they're also AES67 compatible. Now, looking at another range of products in our portfolio, the CDD-LIVE product and SXP, formerly known as the CSX-Live, are both Dante-enabled also, with audio and ViewNet transported over a single Ethernet connection. So these products have 2 onboard Ethernet ports for daisy chaining of devices. They do, however, have a fixed sample rate of 48K and configurable low latency down to a millisecond. They do feature locking nitric Ethercon chassis connectors on the back panel, and they also have an auto-detecting input selection for convenient plug and play. So these guys host the Dante Ultimo chip opposed to the Brooklyn 2 in the iKon. So now if we look at networking topology with Dante, iKon, both iKon and CDD-LIVE, and when I talk about iKon, I'm also referring to the DX4 processor, will automatically connect to a computer without the need of a switch or DHCP server. However, we do recommend that this is for maintenance or testing only. When using DHCP or setting up a static network, we can daisy chain up to 8 CDD-LIVE or SXP cabinets, which are both running Dante and VNet control. iKons cannot be daisy chained, however. We need to implement a network switch or a router in order to connect them on the larger network. So the recommended topology for deployment, not only for iKon but also for CDD-LIVE, is to use a star topology, which looks something like the image in this slide. This is achieved by linking switches to one another, and all devices are connected to its own switch port. So the reason we do this is quite simple. It is expandable. We don't have to worry about anything happening downstream. If we lose a device upstream, we haven't lost anything past it. And it also keeps latency to a minimum, as it's minimizing hops between switches or devices. So a couple of considerations when we're looking at setting up a network for Dante and indeed for VNet control. They, of course, will easily coexist on a standard IT network. So we can use just the one network for both VNet control and audio via Dante. So for these networks, we recommend using unmanaged gigabit switches with Cat5e or Cat6 cable or higher indeed. And simple connectivity and audio flow can be achieved using DHCP support and ensuring all devices are set to auto. So a little note and a good one for any situation. When we are using static IP addresses, make a note of the IP addresses for CDD-LIVE and SXP products. So here I'm talking about the control address, so the one that talks to VNet. As there's no back panel display of CDD-LIVE, it's just always handy to scribble it on with a Sharpie and a bit of tape on the back of the cabinet so you know in case they go out anywhere or you forget. Also, make sure we always connect in a star configuration where possible to reduce the risk of losing devices, keeping latency to a minimum, and better management. And each Dante enabled product will not only have its Dante IP address, but also device IP address. And in the instance of a redundant device, such as iKon, a second Dante IP address pertaining to the secondary network. So we have a quick look at network configuration for devices. So here I'm talking about the Ethernet connection that we're going to plumb in to talk to VNet. So as I mentioned, iKon amplifiers support full redundancy. There are separate network ports on the back panel for primary Dante, secondary Dante, as well as VNet. So common practice would be to include the VNet control on the primary Dante network, as shown here. So to achieve this, we simply plug 2 Cat5 cables or Cat6, whatever we like, into one switch, feeding from the Ethernet port on the iKon as well as the primary Dante, and then a completely independent network running the secondary Dante or the redundant Dante. So as I mentioned, we can set iKon amplifiers to both an automatic and static IP address. By default, they are auto. So in auto mode, iKons will be allocated an IP address from DHCP if there's one present on the network. If not, they will obtain an IP address automatically. This can take a few minutes, however. And this protocol is called a PIPA, or Automatic Private IP Addressing. So this is a Windows function that provides auto configuration addressing. It assigns as what's known as a Class B IP address, and this ranges from 169.254 00 all the way up to 255.255. So there's a lot of IP addresses there available for self-assigning. In this configuration, the subnet mask of the icons is set to 255.255.00, which means they will be able to talk to any interface with a device in the IP address range above. And the good news is that Dante products will also automatically assign within the same range. So even without a router or a DHCP server on the network, we can talk to both VNet and Dante simultaneously. So in order to change the IP address of the control port of an iKon or DX4, it's achieved from the front panel. So first of all, we hit the utility button, press the up arrow twice to toggle to the mode page. And here we can see it's set to auto on the IK42. If we wish to change that, we can hit the adjust knob, which will make it static. Now in static mode, there are 4 available ranges, which are 192.168, the 169.254 we've already mentioned, 10.0 through 10.255, and a 172.0 to 172.255. So to cycle between these ranges, again, we use the adjust knob. And once the desired range has been chosen, we can select and move to the next column, allowing us to set our IP addresses as we need to. So of course, then it's a combination of using the select knob to choose your column and the adjust knob to change the IP address. So the important thing to note here is that all devices on a static network must be in the same range, and they must all have a unique address. So now we're going to look at doing the same procedure for a CDD-LIVE or SXP product. So again, these will obtain an IP address automatically by default. Same with the iKon. If there's no DHCP online, it will self-assign in the same Class B range. However, in order to change them to static, we need to use VNet. And just a reminder that we're looking at the device IP address, not the address relating to Dante at this stage. So first, we must open a VNet project and discover our devices. So once we open VNet, what we need to do is start a new project. So we can either click the new project icon or File New will also open the project window, and then this little pop-up will appear. So here we simply give it a name and a file location and hit Finish. And then it opens up these options along the menu tab. Simply click Discover Devices, and now VNet will search for any compatible devices on the network. When devices are discovered, click Run Wizard to sync these with VNet. And once that's done, they'll appear in the workspace ready for control. So we'll look at the IP addresses for CDD-LIVE and SXP now. So now that we've discovered it, we can find our device within the workspace, right click on it, select IP settings, and we'll get this little pop-up window that's shown here on the right. So by default, it is set to obtain an IP address automatically. In order to change that, we simply set IP address manually, enter the IP address that we want to, and then hit save. Now at this point, of course, if we've set the IP address in a different range from one we were already working in, the device is going to come offline. And before we can rediscover it, we're going to have to change our PC's IP address to one within the same range. And if in the instance we can't discover a device and we know it's been set statically, what we can do is reset the CDD-LIVE product by pressing and holding the preset button until all 4 lights are illuminated. This takes approximately 10 seconds, power cycle the device, and it will revert back to its default automatic IP setting. So as I've already mentioned, there is no display showing the IP address on the back panel of the device. So we must either reset it this way or we cannot connect to it. So now we're going to have a look at just quickly setting the input source of an iKon and then a CDD-LIVE to Dante so we can get some audio flowing. So once we've done that discovery process and we're connected, double clicking on a product, regardless of it being an iKon or a CDD-LIVE, will bring up its editable features. So in order to set the amplifiers to Dante, we'll click the routing tab in the bottom left of the screen, change our type. So we have a choice between analog, AES, Dante, and none. And providing that we have a Dante stream available, we'll see input and output across the amplifier channels, which can be seen in the gains, mutes, limiters page. So just quickly about the back panel of the CDD-LIVE. As I mentioned, the Ethernet connections on CDD-LIVE will carry both VNet control and Dante audio. It's worth noting that the two Ethernet connections are routed to a 2-port switch, therefore they do not function as redundant Dante. The Ethernet ports do have some LEDs though to show different operational states. So the green shows that the port is operational and should illuminate as soon as a connection is made. And the yellow is to show the data speed, it will flash. And then there's a little Dante LED as well, which will illuminate when a Dante feed is present on the network. So double clicking on our CDD-LIVE product will bring up all of the CDD-LIVE that we have included within our project here. And what we can do is change the input source just by selecting where it says input underneath the delay parameters and choosing analog or Dante. By default, it's set to auto. So there's a hierarchy here in that if Dante audio is present, this will be the primary input source. However, if we lose the Dante audio and we have analog also connected, it will fall over to analog. So VNet also features a global input source function for all of the CDD-LIVE and SXP devices. So any product, any CDD-LIVE product we have within this window, we can globally change to analog, Dante, or auto. Okay, now we're going to move on and have a look at Dante Controller a little bit. Excuse me. So Dante Controller is the proprietary software for routing and managing Dante devices in our network. And when we open the software, this is the first screen to appear. As we can see, hopefully if we've got our network all up and running correctly, all connected devices have automatically appeared. And we can see transmitters along the horizontal axis and receivers along the vertical. So we'll just have a quick look through the architecture of the software. There are 4 menu tabs along the top of the controller. First being File, where we can load a preset, save a preset, or exit the software. Then Device, where we can refresh the software or enter device view. Then View, where we can toggle various states of windows within the software. So the channel groups, which we'll talk about in a moment, show any hidden devices or domain manager configuration. And then a Help tab, where we can look at licensing, check for updates, as well as toggle to help sections, be that the online website or the user guide. And below the menu bar, there's a quick access toolbar where we'll find all the common use functions within the controller. So the first being the filter pane. So here we can filter devices in the view by parameter. So clicking the little plus symbol will allow the drop-down options to appear. And checking the options will automatically start to filter the transmitters and receivers in the main project window. And you can see there by on the latency, it's gone red to show that there's a filter active. And we can also filter by name in the filter transmitters, filter receivers windows on the main project window, and these will always appear here. And we can apply multiple filters between the filter pane and the transmitters receivers filters. Finally, there's a nice clear all function, which will remove all filters throughout the software and bring all devices back to the main project window. Next tool along is the reload device information toolbar. So if, for example, a change has been made, a new device added to the network, for example, and we haven't yet seen it, it's just good practice to reload the tool, which is a quick and easy way to update all the information. So next I want to talk a little bit about Dante presets. Presets are device agnostic, which allows us to swap physical devices and load the information required onto any device. So this is handy if, for example, we've lost a device that has a Dante card and we've done some routing. We can simply, as long as we have a preset saved, which is good practice to do anyway, we can swap the device out, load the preset in, and all will be as it was. So we can also back up and restore network configurations or create special periodic events and switch back when we need to. And another really handy feature of the presets is we can globally apply one or more settings to a number of devices simultaneously, regardless of the device. So for example, setting every device on our network to the same sample rate. So when we click on the Save Preset button, this window appears, and here we can select which devices present on the network are included. Clicking the Advanced button brings up a list of parameters that we can choose to be included within the preset. So we can check or uncheck these as we desire. And as you can see, there are a couple of grayed out functions which are device specific and will only be enabled when a supporting device is online. Once we've assigned all the devices we wish to and the parameters, we can then hit save, and this will open a file directory somewhere on the computer. So coming back to the quick function toolbar, we have the open preset tool here, which allows us to quickly recall a previously saved preset. So we can do this here. We can also click Control O or File Open Preset. Once we've found it, we can hit Open, and this window will appear. So the first column here allows us to choose which of the parameters that we saved we wish to apply to this loading preset. So it works in the same way as kind of a console snapshot scope. Again, the grayed out selections are device specific. The next column along indicates which devices are included within that preset that we saved. If there are devices missing on the network, they will not appear with the green checkbox. And the next column indicates which devices are active on the network. So these are devices that we currently have connected. And as we can see, the gray text shows an automatic assign from the preset roles column to a destination. So if a different like-minded device, as I've mentioned earlier, is found on the network, it can be allocated from a preset role from the left column, simply by clicking on the device we wish to move and its target, and then hit Apply Role. And the final column displays any error messages. So here we can see a conflict with the naming. To rectify this, we simply uncheck the name tab within the presets element column on the very left. And now all the issues are resolved and we can load the preset. So it's a really powerful tool and really good habit to get into of saving Dante presets, particularly in install situations or if you're doing repeatable work with Dante enabled devices. So the next tab along, and one that often catches people out, is the Dante interface. So this is where we choose which physical interface of our computer we use to communicate with devices on the network. And the icon shows the status and the link speed of the connection. So here we can see it's a 1 gigabit a second link. And we have individual control over both the primary and secondary interface. There's also a shared Dante interface button that allows the selected primary interface to be used by all Ordinate software applications, and this only supports a wired connection. So it's worth mentioning that we can control Dante wirelessly, albeit that we cannot transmit audio wirelessly from Dante Virtual Sound Card or Dante Via, but we can control it. The next tab along is the clock monitoring tab. So again, good practice to get into is have this enabled in your Dante controller, and we can toggle this on and off here. And this is where Dante controller will actively monitor the behavior of supported devices to identify any signs of instability on the clock source. By default, it is turned off, but passive clock monitoring is always on. So what does that mean? That means passive clock monitoring reports and logs critical events, such as the device losing or regaining clock sync with its master. And on the bottom right corner of the software, there'll be a monitor that turns red when this happens, and it will show in the event log. When we toggle clock monitoring, active clock monitoring on, Dante controller will also log any instabilities within that clock, as well as the critical events. And they'll be logged, and now the clock status monitor will turn amber. So as I mentioned, it's a good habit to get into this, just to ensure that we can avoid any clock sync errors before they happen, as they come up as a warning. Next one along is show and hide channel groups. So this allows a channel group filter to be placed to each product in the routing page and dividing up devices into different groups. So Smart and Audio products really only vary between 1 and, it says 4 here, but we're actually on 8 now. It's not particularly necessary to use channel groups. However, a multi-channel device such as the Focusrite RevNet, however, will do a 64x64 transmit receive. So here we can just filter the device outputs in groups of 16 just for easier manageability. And the final tab is the Dante Domain Manager configuration. So here we can just connect to Dante Domain Manager and log in. We don't particularly use Dante Domain Manager here at Martin Audio, so I'm not going to go into great detail about it. If you do want to learn more, there's a hyperlink there to Ordinate's link on Domain Manager. Right, so let's have a look at patching some transmitters to receivers in Dante Controller. So to patch two devices, it's simple as clicking in the matrix between the transmitter and receiver. So here we can see that we've patched music left, or channel 1 from Ben Control PC to 01 on CDD-LIVE 8 left. Of course, the CDD-LIVE cabinet only has one receive channel, so it'll always be 01 by default. The timer indicates the subscription in process, and then after a few seconds, it will change to a green tick if successful. Another way to patch devices together is to use device view. So device view can be accessed in one of three ways. In the main menu bar, as we already saw, device view, Control D, or double clicking on a device name in the routing page. So here, what we can do now is click in our transmitter from our available channels column on the right into a receiver. And the nice thing about this is you can shift click anywhere on below and drag in multiple channels simultaneously. So really quick and handy if you're running virtual soundcheck, for example, and you need to pull in 64 channels one-to-one, you can just select them all here, drag them into the appropriate receiver, and you're good to go. So device view is a powerful tool, and it's where we change the channel names for both receive and transmit channels. So to do that, we just simply click on the channel, which is numbered by default, start typing a new name, and we can use the tab key to quickly cascade through the channels in order to name them. Naming in this tab works in exactly the same way, except each channel has a designated channel label as well as its number. Okay, so if we see this subscription errors pop up on our subscriptions, this means a subscription has not been completed. Most commonly, this is going to happen if the sample rate of a device has changed. So here we can expect that the IK42 device now has a different sample rate to others on the network. Hovering over it will display a message relating to the issue. And we go back to the device view to fix the issue. So coming in here, we can see that the Dante stream from the PC is terminated. And to rectify this, we're going to go to the device config tab, which is highlighted in blue there. And in this page, we can do quite a lot. We can rename the device, change the sample rate, change the device encoding, enable unicast delay requests, change the device latency, and reset the device. So for integration with Martin Audio products, this is quite a well-used page. ensuring that our Dante cards are in line with the names that we've given our amplifiers in ViewNet, as well as making sure all the devices are on the same sample rate. And if we're using multiple amplifiers to run loudspeaker arrays, for example, they're also on the same latency. Some devices, for example, the CDD-LIVE and SXP, are fixed 48K, as I've mentioned, and do not allow us to change the sample rate. They're also not AES67 enabled. So going back to the project window earlier, we know that we made a successful subscription between the PC and the CDD-LIVE. So we know that a PC has a sample rate of 48K also. However, here in this window, that we can see the IK42's sample rate is 96K. In order to change this, we simply open the drop-down menu, select our new sample rate from the selection, in this case 48K. We'll get a confirmation message. And now back in the main project window, we can see that the subscription is now completed and audio will resume. So the next thing to look at within these devices is latency. So this is to account for delay between audio packets leaving the transmitter, winding their way through a network and reaching the receiver. If a receiver's latency is set too low, we could lose audio packets. And when this happens, it's effectively saying we haven't made it to the receiver in time. So we're going to result in having some audio glitches. So it is important to ensure that all receivers have their latency set high enough to prevent packet loss. However, not setting them too high so they interfere with low latency application. So it's important to find a good balance between low latency and audio integrity. So again, back in the device view, we can have a look at the latency of a receiver. If packets are arriving near the limit of the latency setting, the histogram will display the bars, in amber. If they start displaying in red, it means the late packets are arriving and we're getting audio loss. So we must now change the receiver latency or reconfigure the network so there's less hops between the devices. Once the change has been made, we can then refer back to the latency tab, and the histogram should now show green bars towards the left or middle of the screen to show that all the latency settings are good. So now we're just going to have a quick look at a bit of topology again about network for Dante. So I mentioned earlier, we'd commonly have our ViewNet control on the same network as primary Dante and a completely independent one for the secondary Dante. So we do this because they're effectively two identical networks. Dante mirrors all of the audio subscriptions made on the primary network to the secondary in case of failure. So it's important that in no stage do these networks intertwine. I mentioned going back to DHCP as well, because we're putting ViewNet on the same network, this is commonly where we would place our DHCP support. And given that Dante devices are much quicker at self-assigning IP addresses, we don't need to concern ourselves with having DHCP on the secondary network. In Dante Controller, we have these tabs also. We can toggle device view, which tells you information about the name of the device, the product type, its version, its Dante version. We can lock the device, and we can see their Dante IP addresses and link speeds for both ports. So commonly, redundant Dante networks will self-assign all of the secondary device ports in a different range from the primary. So here we can see they're set to 172.31. Whilst the primary network is in a 192.168 range. But we can of course set static IP addresses to Dante also. So to achieve this, back in device view, our ever so familiar page, and we toggle now to the network config. And it works in the same way as CDD-LIVE really. We can select manually configure an IP address, enter the credentials as necessary. And it's worth noting as well, as you can see, there's independent control for the primary and secondary. We can then click apply, This will prompt the power cycle of the device for the effect to take place, and it's good practice just to turn the device on and off, ensuring then that your IP address is changed. Once again, if you want to control the device or indeed send audio from a laptop to it, you need to ensure that your computer is in the same range. So now we're just going to have a quick look at setting a static IP address for a Windows 10 computer, because we do actually get quite a few questions about how to do this. So to do it, click Start and Settings, Network and Internet, click Ethernet from the left column, change adapter options, right-click on the desired interface, there's Properties, select Internet Protocol version TCP IPv4, click Use the following IP address. We can see that it's set currently to obtain automatically. Input our desired static IP address and subnet mask, and click OK. So we've covered quite a wide range of things here. So we can have a little summary now. Dante is widely regarded as a plug-and-play solution, and of course, if we're using DHCP support for both VNet and Dante, and everything's set to auto, it should be a simple case of plugging it in, routing your transmitters to receivers, and you're good to go. We use Dante controller to name, patch, and edit devices on the network, as well as monitor things like clock status, etc. Dante will happily coexist on an IT network, allowing audio and control of our products along with any other network traffic to share a single network. It's important to remember that Dante-enabled products will have independent IP addresses for device control and Dante, and of course, if it's a redundant Dante device, the second Dante network. Device names, sample rates, and latency are the most common cause of device error on the network, so now we know where to look for them if we do have problems. And where possible, always recommended to use a star topology for networking, and this doesn't just pertain to Dante, but anytime we're introducing network products to our system, it's always good practice to route them all independently. And for quick implementation, use DHCP and set all devices to auto. So I mentioned at the beginning, this webinar was an introduction to Dante and Martin Audio products. The hyperlink here will send you to a PDF document from Ordinate, which has a lot of in-depth learning about managed networking in Dante systems. It talks about digital audio transport with terms like clocking, bit depth, and discusses the difference between unicast flows, multicast flows. So it's a really good document to have, and should be able to help you get through anything you need to. At this point, that's kind of it from me.